Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to write functions in multiple ways and recognize function notation, to recognize patterns in functions to determine whether or not those functions are linear, how to recognize coordinates in terms of x values and y values, how to plot points on the coordinate plane, how to recognize patterns in the graphs of linear functions, how to determine how the slope and y-intercept will affect the graph of a linear function, how to find a function value of a linear function, how to find the slope and y-intercept of a function from an equation, how to take a linear equation that is not written in slope-intercept form and convert it to slope-intercept form, how to graph linear functions using slope and y-intercept, how to manipulate the slope and y-intercept to change the steepness and location of a graph to suit the needs of the question, to recognize practical applications of mathematics within your area of interest such as basketball, to find the y-intercept of a linear function given the slope and a point on the line, and to find the equation of a line given the slope and a point on the line. How are we learning this? Through the Linear Functions Review Part 1 notes and the Linear Functions Review Part 1 assignment. When can you use this information? To recognize patterns in your spending so that you can figure out how to save money to buy a car, to determine the location of appliances, furniture, and walls when planning to remodel your house, to determine how long it would take to save up enough money for a down payment on a car, to calculate the amount of money in a savings account, to change the appearance of difficult tasks so that it looks more like something you are used to seeing, such as changing your grocery list into a list based on the aisles where you will find them, and to improve your ability to read between the lines and fill in gaps that are not given, such as putting together a bookcase with directions that are incomplete. How do you know you learned it? By getting a score of 4 on the Linear Functions Review Part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Linear Equations Review Part 1 notes, and then I'll give you time to complete the Linear Equations Review Part 1 assignment. Once you've completed the assignment, we'll go back over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Linear Equations Study Guide and any incomplete assignments that you may have. Let's take a look now at the Linear Equations Review Part 1 notes. The notes begin with the learning goals and success criteria. Now let's talk about the components of a function. A function is a relation in which each element of the domain is paired with exactly one element of the range. The domain is all of the input or x values in a function. The range is all of the output or y values in a function. Therefore, a function, meaning that for every x, there's exactly one y that matches it. So in looking at this, we're given a table here, and we're supposed to pick out the range and the domain of each of these. So first we'll do the domain, the input values. Well, our input values in this case is the month, so we're just going to list the values that apply. Well, we can see that the values are 1, 2, 3, and 4, so that is our domain, 1, 2, 3, and 4. The range are these values here. So our range would be 2, 4, 6, and 8. So we have our domain, we have our range. Let's try another one. So here we have 0, 2, 3, and 6 for months. That is our domain. And our range comes from this column here. So we would have 6, 3, 4, and 8 as our range. So that's domain and range. Now, understanding functions. Notice here, we have a domain here, and we have a range here, and they're mapped to each other. So when x is 2, y is 8. When x is 3, y is 12. When x is 4, y is 9, etc. And the question is this a function? Remember, in order for it to be a function, there has to be one y for every x. So if I look at this, I can see that my 2 is only mapped to 8. I can see that 3 is only mapped to 12, 4 is only mapped to 9, and 5 is only mapped to 17. So therefore, this is a function because there's no split. I don't see 2 going to 2 different places. Let's look at another example. We have a domain here, and notice now the question is this a function? We have the domain here and the range here, and notice 2 is mapped to both 8 and 12. So therefore, this is not a function because 2 is mapped to 2 different places. Remember, for every x, this is our x, for every x, there can be only one y that goes with it. 4 and 5 are okay. 3 is actually okay even though it's not mapped to anything. The issue is 2. Okay, let's look at another example. So this one says for every number in the domain there can only be one number in the range. And is this one a function? Well, we have 2, 3, 4, and 5, and 2 is mapped to 8, and 3 is mapped to 8. So there's 2 numbers going to 8. The question is that okay? The answer is yes, it is okay, and this is still a function because 2 is only with 8, and 3 is only with 8. It doesn't matter that they're both going to the same place. The issue would be if x is mapped to 2 places, but each x, 2 and 3, are only mapped to one place. They're just mapped to the same place. So yes, this is still a function. How can we tell if something's a function by a graph? Well, we use what we call the vertical line test. So again, for every x, there can be only one y. So if I pick an x like 5 here, I can see that when x is 5, y can be this number here, whatever that is, maybe 14 or so. And y can be here, which is -4. So in this case, this would not be a function because there's 2 numbers. Now the easy way to check this is what we call the vertical line test. I can draw a line anywhere on the graph, and if I draw the line anywhere on the graph and it touches the graph in 2 places or more than one place, then it is not a function. So I can see here, I drew my line in and it touches there and there. So when x is -10, this is not a function. So therefore, it's not a function. And if it only happens once, it doesn't matter how many times. In this case, I can draw a line almost anywhere and it's going to be not a function. But if there's even one place where I can draw it and it's not a function, then the whole thing is not a function. Now what about this one? Is this one a function? Well, let's take a look. Is there any place I can draw a line? Notice I drew several lines in different places, and no matter where I drew the line, it still only crosses in one place. So even though the graph looks really funky, right? It goes up and down and up and down. I still can't cross in 2 places, so therefore this is a function. Okay, functions can be written in 2 ways. We can call it f of x equals some function, right? I can write the equation for the function there. Or I can say y equals some function. So you probably heard the term y equals mx plus b before. Well, what I'm telling you here is that it doesn't always have to be y, it could be f of x. So f of x equals mx plus b, and that means the exact same thing as y equals mx plus b. From that then, I can find a function value that corresponds to the domain value of some number, which in this case I'm going to plug in 3. So let's say I gave you that f of x, or it could be y equals, right? F of x equals 2x minus 3. And I want to know what happens when the domain value is 3. Remember, the domain is x, so I'm going to plug 3 in for x. So this becomes 2 times 3 minus 3. Now I solve, so I'm going to multiply 2 times 3, and I get 6. 6 minus 3 is 3. So when x is 3, y is also 3. And if I were to plug in any other number, so let's say this was 4, I would just plug 4 in for x. If it was -8, I would plug -8 in for x. So whatever number they give you, that's the number you plug in for x, and then solve. Linear relations. What makes something linear? A linear relation occurs when the graph of the relation set forms a straight line. So we have a graph here, and we plotted all the points that they gave us, and when we did that, it forms a straight line. That's a linear relation. Notice that as the x values change by 1, the y values change by the same amount each time. Meaning that as we go through, it keeps stepping up the same amount each time. How to read a table? The columns are the vertical cells in the table. So this is a column and this is a column. And then we have rows, which are the ones that go horizontally or side to side. These are our rows. We always label the columns. So in this case, we're calling this one time in months and this one temperature in degrees. And then we put in our table. So we fill it in with the data points. Now the columns separate the two variables. So this separates time from months. And the rows separate the actual data. So this is a data point. This is a data point. This is a data point, and this is a data point. So in this case, we're going to try to recognize what pattern we see in the columns. So if we look here at the time, we see that each time we go down one level on the rows, that we're adding 1. So we could say that time is moving up from one row to the next, and the pattern is consistent, right? We didn't have add 1, add 2, and then add 1. We're consistently adding 1. Next, let's look at the temperature. Well, is there any kind of pattern here? Well, from here to here, we're adding 5, and then adding 5, adding 5, and adding 5. So therefore, the temperature is moving up by 5 from one row to the next, and the pattern is also consistent. So the temperature is going up by 5 degrees every 1 hour. That's what we can say based on the pattern we see from the table. Now from that, can we tell if these patterns are linear or not? Well, if the changes in the data are consistently changing by the same amount, and that amount is in the form of addition, it is a linear relation. So let's take a look at the table. So we have our months, and we look and see that there is a steady change. We're adding by 1 month each time. And in rainfall, we can see that we have a consistent change also. We are adding by 2 inches each month. Therefore, if we were to plot these points, it would look like this, and therefore we can see it does form a straight line, and yes, it is linear because we have a consistent change of addition and a consistent change of addition. Let's look at another example. So we have our months here, and we can see that they are adding by 2 each time. So therefore, yes, there is a consistent change. In this case, we're adding by 7, and then 7 again, and 7 again. So yes, there is a steady change, and it changes by 7 home runs. So therefore, is this linear? Well, we have a consistent change of addition, and we have a consistent change of addition here. So therefore, this is linear. Now we can take a look at it another way in terms of perimeter. So this is kind of a geometric application to this. So if we have the perimeter of this block here, we know that this side is 2 and this side is 4. So now we're going to see that this side is also 4 and this side is 2. We know that perimeter means the sum of all the sides, or adding up all the sides. So this is 4 plus 4, which is 8, plus 2 is 10, plus 2 is 12. So that's my perimeter for the first one. Now we do it for this one. This is 2, and this is 4. So that means this side also has to be 4, and each of these sides has to be 2. So that's 2, 2, and 2. So if we add all these up, this is 4 plus 4 is 8, plus 4 is 12, plus 4 again is 16. And then again, we add these up. This is 4 and 4, and then 2, 2, 2, and 2, 2, 2, and we get 20. So now, if we were to do this by the number of rectangles and the perimeter, so this is one rectangle here, which was a perimeter of 12, two rectangles was a perimeter of 16, and three rectangles is a perimeter of 20. Therefore, we want to know, is this linear? Well, we're adding by 1 each time here, so that's consistent and addition. We're adding by 4 each time here, that's consistent and addition. So yes, it is a function, and it is linear. Now let's take a look at axes. So within the coordinate plane, we should notice that there's these lines that break up the x and y's. The axes are the thick lines that break up the positive and negative values. So if we look here, we have our x's here that go this direction, and we have our positives on this side and our negatives on this side. And they're broken up by this line here that represents the negative y's and the positive y's. So they break up each other and create positives and negatives in each of these boxes. The x-axis is the one that goes side to side, and it's usually labeled, but sometimes it's not. This is the x-axis that goes side to side. The y-axis is the vertical axis, the one that goes up and down. This is the y-axis that goes here. From that, we form what we call quadrants. Quadrants are these boxes that are created from the axes. So this is a box, this is a box, this is a box, and this is a box. And we label them I through IV, or 1 through 4. So this is quadrant 1 right here. This is where we begin. And then we go counterclockwise this way around to create the other boxes. So this is quadrant 2, this is quadrant 3, and this is quadrant 4. Notice each quadrant represents positive or negative x values and positive or negative y values. So for instance, quadrant 1 represents positive x values and positive y values. Quadrant 2 represents negative x values and positive y values. Quadrant 3 represents negative x values and negative y values. And quadrant 4 represents positive x values and negative y values. Now, how do we plot points on the graph? Well, first of all, we're given ordered pairs. Ordered pairs are single components of a relation containing an x value and a y value. So what that means is we're given an x and a y. For instance, this is an ordered pair, -2, 3. So the way this works is my x goes first and then my y. If you have trouble remembering that, just remember that they go in alphabetical order. So x, then y. So my x is -2. So I'm going to go along the x-axis and find -2, which is here. And my y is 3. So I'm going to go along my y and go up to 3, right there. And I'm going to plot my point. That represents -2, 3. Then we have -4, -6. Well, -4 on my x-axis, so I'm going to go find -4 on the x's, right there. And then -6. So I'm going to go down and find -6, which is here, and plot that point. Then I have 5, 3. So x is 5, so I'm going to go and find where x is 5, which is here. And y is 3, so I'm going to go find 3, which is right there. And there's that point. And lastly, I have 1, -3. So x is 1, so I'm going to go find 1 on the x-axis, which is here. And -3 on the y-axis, which is here. And I plot that point. And now I have plotted all 4 of these ordered pairs. Now, part of this is being able to plot the points, but the other part of it is being able to recognize the points once they're already graphed. So in this case, I'm given some points and asked to find where those ordered pairs are. So let's look at A, which is here. Well, I can see that my x value is 1, 2, 3, and my y value is down 1, 2, 3, 4. So it's x equals 3, y equals -4. So that would be my point for point A. Then I can do point B. Point B is right here. So I went to the right 1, 2. So x is 2. Y is 1, 2, 3, 4, 5, 6. So I would be at 2, 6. Then I find C. C is here. So that's negative 1, 2, 3, 4. And my y is negative 1, 2. So C is negative 4, negative 2. Then I do D. D is right here. So that's negative 1, 2, 3, 4, 5. And negative 1. So negative 5, negative 1. Then E. E is here. So that's 1, 2, 3, 4. And then negative 1, 2. So it would be 4, negative 2. Then F is here. So that's negative 1 and negative 1. And then G is here. So G is 1, 2, 3. And then 1, 2, 3, 4, 5. So 3, 5. And then H is here, which is negative 1, 2, 3, 4. So negative 4 and 1, 2, 3. So negative 4, 3. And so that's how I can look at graphs of coordinates and be able to figure out what their ordered pairs are. There's a video here now that shows you how to check your coordinates in Desmos. You can watch that as well. Let's talk now about how to check our work using Desmos. So on this one, we're going to look at graphing coordinates. So we're going to go to desmos.com and we're going to click on where it says Graphing Calculator. And this gives us the opportunity to now plot points. So we're going to check coordinates and make sure that we did our assignment correctly. So let's say that one of the points was at 9, 2. So we're going to go ahead and put in parentheses 9, 2. And notice it graphed the point for me right there. If I want to add another one, let's call this 8, 4. Again, there's my next point. So I can plot as many points as I need to just in this is by using this format of parentheses and then the x coordinate, y coordinate, and then closing the parentheses. And I can graph any points that I want. So negative 2, negative 5 puts the point right there. So I can graph as many of these points as I need to, and Desmos will do it for me. So that's how you can let Desmos check your work for you. Now let's talk about slope. What is slope? Slope is a rate of change involving x values and y values. Slope is known as for being the change in the dependent variable over the change in the independent variable. Now what does that really mean? That really means that slope is the change in the y values over the change in the x values. So it's always y over x. And the next part you need to know is the y-intercept. The y-intercept is the point where the linear function crosses the y-axis. So we have a line here, and we can see that the y-axis goes here. So where do they intersect? Well, they intersect right there. That is what we call the y-intercept. So in this case, our y-intercept would be 2. Slope-intercept form. Slope-intercept form is written as y equals mx plus b. And what does that mean? M is the slope, and b is the y-intercept. Y and x are my variables that stay variables so that I can plug numbers in and see what they come out to be. So m is the slope and b is the y-intercept. Now how can I remember that? The easiest way I remember this is m represents the slope because it's a slippery slope to get hung up on your x. So think about it in terms of relationships. People that are involved in relationships and they break up, there's usually that one person in that relationship that's always hanging on to the relationship that's already dead. That's the slope. That's M. It's a slippery slope to get hung up on your ex. They are not together anymore. But the M is always trying to hang on. Notice how close they are. So M is trying to hang on, and it's a slippery slope to get hung up on your ex. Now B, on the other hand, is alone. Not attached to anybody. B is lonely. And lonely people ask the questions, why am I alone? Why does no one want me? Why does no one think I'm cute? That's B. B is always asking the why questions. Those are the y-intercept questions. So that's the way I remember it. It's a slippery slope to get hung up on your x, and why am I alone? So that's the way I remember slope and y-intercept. Now, let's go ahead and pick out the slope and y-intercept from an equation. So we're given an equation, y equals 2x plus 4. And we want to know what is the slope of that line. Well, we know that the slope is the one that's attached to its x, right? So it's a slippery slope to get hung up on your x. So the one that's attached to the x in this case is 2. So the slope is 2. The y-intercept is the lonely one. Why am I alone? Well, the lonely one is 4. So my y-intercept is 4. So that's how I pick out the slope and y-intercept given an equation. Let's look at another example. We have y equals negative 3 halves x minus 3. Well, same thing. It's a slippery slope to get hung up on your x. So the slope is the one that's attached to the x, which is negative 3 halves. So that's my slope. And my y-intercept is the lonely one. Well, the lonely one in this case is negative 3. So B is negative 3. So that's how I find the slope and y-intercept from an equation. Now, how do I write the equation from a graph? Well, I'm going to use the slope, which is the change in the y values, over the change in the x values. So I'm going to pick out 2 points. Luckily, they've already done it on the graph for me. And I picked this point, and I'm going to calculate the change in y. So how far down in this case did I go to get to here? Well, I went down 1, 2. So my change in y is negative 2. And I went to the right 1, 2, 3. So that's positive 3. So my change in x is 3. So it's negative 2 over 3, which is negative 2/3. So that's my slope. Well, the y-intercept is the y value when x equals 0, which in this case is right here. So my y-intercept is 3. So now I know my slope and I know my y-intercept. So I'm going to plug that into y equals mx plus b. Remember, the slope goes where m is. So the slope is negative 2/3. So this should say y equals negative 2/3 x. And b is 3. So I'm going to plug that in. So my equation for this line would be y equals negative 2/3 x plus 3. Now, how do I graph a linear function? Well, first thing I need to do is pick out my slope and my y-intercept. Well, in this case, my slope is negative 1/2 because that's attached to the x. Now, my y-intercept, notice there's nothing here. There's no lonely people. So how do I say none in math terms? Well, that's 0. So my y-intercept is 0. So now when I graph this, the first step is I plot the y-intercept. Well, my y-intercept is 0. So I'm going to go along my y-axis and find 0, which is right here. And I plot my point. The next step is I'm going to use the slope to plot my second point. Remember, this is change in y over change in x, or you might have heard it in the past as rise over run. We're going to talk about it as change in y over change in x. So my change in y is negative 1. So I go down 1. And my change in x is 2, so I'm going to go to the right 1, 2, and plot my point. So now I have my first 2 points. The next step is just to connect the dots and draw a line between them. So I'm going to connect the dots. And now I have a linear function that is graphed that goes through 0 and has a slope of negative 1/2. Now, what do I do if the equation's not in slope-intercept form? Well, that presents a problem. I can't actually graph it unless it's in slope-intercept form. So I know that it needs to look like y equals mx plus b. So I need to get y by itself. So anything that's not y, I'm going to move to the other side. So I'm going to begin with this 4x here. And I'm going to move the whole thing, because if I just move the 4, then the x is still here. Well, I don't want the x to be there. I want the x to be on the other side. So everything must go. So if this is positive, I'm going to subtract it. If it was negative, I would add it and get rid of it and move it all to the other side. So I'm going to subtract 4x. Well, 4x minus 4x is 0, so that's gone. So now I'm left with 10 and negative 4x over here. So I'm going to rewrite this as negative 2y is equal to negative 4x plus 10. Now I'm going to get rid of whatever's over here with the y. Well, I got a negative 2 over here, and it's being multiplied by y. So I'm going to undo that by dividing. So I'm going to divide both sides by negative 2. That gets rid of this, because negative 2 divided by negative 2 is 1. So it's just 1y. So that's what I want, just y. And then this gets divided to both of these. So negative 4x divided by negative 2 is positive 2x. And 10 divided by negative 2 is negative 5. So I end up with y equals 2x minus 5. Here's my slope. Here's my y-intercept. Now I can graph that equation. Let's look at another example. We have 4y plus x is equal to 64. Well, same thing. I'm going to go ahead and get rid of the x first. So it's a positive x, so I'm going to subtract x to get it to the other side. And I'm left with 4y on this side. And I got negative x and 64 over here. So I got 4y is equal to negative x plus 64. Now I need to get rid of this 4. The 4 is being multiplied by y. So I'm going to undo it by dividing both sides by 4. And 4 divided by 4 is just 1, so that's 1y, which is what I want. And now I have negative x, which is really negative 1x, divided by 4, and 64 divided by 4. Well, negative 1 divided by 4, I can't actually do that, so I'm just going to leave it as a fraction. So that stays as negative 1/4 x. And 64 divided by 4 is 16. So I'm left with y equals negative 1/4 x plus 16. One more example. We have 4y minus 4 is equal to 3x. Well, the x is already over here, so the only thing I got to get rid of is this 4 and this 4. So I'm going to get rid of this one first. So I do that by adding 4 to both sides, which leaves me with 4y is equal to 3x plus 4. Now I'm just going to get rid of this 4. This 4 is being multiplied by y, so I'm going to undo that by dividing. So I divide both sides by 4. And I get 3 divided by 4, which is just 3/4 x. And 4 divided by 4, which is 1. So I'm left with y equals 3/4 x plus 1. Now what if I'm given 2 points and asked to find the slope? Well, first thing we need to remember is that coordinates are written in the form x and y, right? So the x goes first and the y goes second. And that slope is the change in the y over the change in the x. So what we're going to do is we're going to take these points and we're going to subtract the y values and put that as my numerator, and subtract the x values and put that as my denominator. So when I do that, I get 1 minus 2. Those are my y's, so that's my change in y. So my change in y is 1 minus 2. And my change in x is 2 minus 4. So that's change in y over change in x. Now when I do that, 1 minus 2 is negative 1. And 2 minus 4 is negative 2. And when I do that, a negative divided by a negative just becomes a positive. So this is just 1/2. So my slope for that line that goes through those 2 points is 1/2. Let's look at another example. So what is the slope of the line that passes through negative 3, and 2, negative 6? Again, coordinates are written as x and y. So this is my x, this is my y. This is my x, this is my y. And slope is change in y over change in x. So I'm going to calculate that by subtracting my y values first. So negative 3 minus negative 6. And then I'm going to subtract my x values, which is negative 3 minus 2. So I get negative 3 minus negative 6 and negative 3 minus 2. And when I simplify, this really becomes plus positive. So negative 3 plus 6 is 3. And negative 3 minus 2 is negative 5. So it's 3 over negative 5, which is just negative 3/5. There's a video here also that shows you how to graph linear functions in Desmos. So you can go ahead and watch that. Let's talk now about how to check our work with linear equations using Desmos. So what we're going to do is we're going to go to desmos.com, just like this, And we're going to click on the link that says Graphing Calculator. And over here on the left side, we can enter the equation of any linear equation and it will graph it for us. So let's try y equals 2x minus 4. Well, as we can see, it graphs it for us. We can check that against whatever we did on our assignment now. And you can do it this way. Let's say we had an equation, though, that wasn't in slope-intercept form. We can still graph that on here and check our work. So let's say it was 4x minus 2y is equal to 8. And we can see that that's actually the same as this one. But we can look at this and check our work this way as well. It still graphed the equation in slope-intercept form, even though the equation we put in is not in slope-intercept form. So this is one way that you can check your work using Desmos to find linear equations. Now, what is point-slope form? We use point-slope form if we know the slope and one point on the line. We can still create the equation for the line even though we don't have the y-intercept. And here's how we do it. We know that slope is y equals mx plus b, and we plug in the slope for m. So whatever the slope that's given to us, we plug that in for m. We plug in the x value of the coordinate. So we're given some ordered pair, and we're going to plug in the x part here, and we plug in the y coordinate here, and now we're left with only one variable, which is b, and we could solve then for b and get the y-intercept. So let's take a look at an example of this. So it says, what is the equation of the line through 3, negative 2 with a slope of 2/3? So first thing is we take our y equals mx plus b, and we're going to plug in what we know. We'll plug in the slope first. So the slope is 2/3. That goes in for m. So now this says y equals 2/3 x plus b. Then we'll plug in the x value of the point we know. Well, the x value is 3, so we plug that in for x. And then we plug in the y value for y, which in this case is negative 2, so we plug that in for y. And we get negative 2 is equal to 2/3 times 3 plus b. Now we can solve for b. Well, we get 2/3 times 3, so which when we multiply this out, we get 6/3, which is the same thing as 2. So we got negative 2 is equal to 2 plus b. Now we just solve by subtracting 2 from both sides. And we're left with b is equal to negative 2 minus 2 is negative 4. So b is negative 4. So that is the y-intercept. Now we can put that into the equation. So we have y equals 2/3, because that was our slope, x, and b is negative 4, so that's our equation. Now let's look at another example. We have negative 4, negative 1 as our point, and the slope is negative 2. So we're going to start with y equals mx plus b, and then we're going to plug in what we know. Well, we know the slope is negative 2, so that goes in for m. So this becomes y equals negative 2x plus b. Then we're going to plug in our x value. Well, our x value is negative 4, so we're going to plug that in for x. So this becomes y equals negative 2 times negative 4 plus b. Then we plug in our y value. Our y value is negative 1, and that goes in for y. So this is negative 1 equals negative 2 times negative 4 plus b. Now we just solve for b. Well, negative 2 times negative 4 is positive 8. So that's negative 1 is equal to 8 plus b. We're going to get rid of this 8 by subtracting. So we subtract 8 from both sides. And we get negative 1 minus 8 is negative 9. That's equal to b. Now we plug this back into our y equals mx plus b form. Y equals negative 2 x. And then our b is negative 9, so it's minus 9. Let's look at one more example. We're given a point 4, 2 and the slope of negative 3 over 2. So we're going to use the form y equals mx plus b, and we're going to plug in the slope for m, which is negative 3/2. So that goes there. And we're going to plug 4 in for x. there. So we got y equals negative 3 halves times 4 plus b. Then we're going to plug 2 in for y, which is here. So it becomes 2 equals negative 3 halves times 4 plus b. Now we're going to go ahead and solve for b. So when we do this, we get negative 12 over 2, which is the same thing as negative 6. So 2 equals negative 6 plus b. We're going to add 6 to both sides to get rid of that 6, and we get 2 plus 6 is 8, so b is 8. Now we're going to plug that back in, so we get y equals, and we know that the slope is negative 3 halves times x, plus our y-intercept, which in this case is 8, so that goes there, and that's how we write the equation using point-slope form. Let's take a look now at the Linear Equations Review Part 1 assignment. The assignment begins with the learning goals and success criteria, and if we scroll down, we can see the questions for this assignment. So the first one says, which of the following notations are equivalent to the function below? It says y equals 2x minus 4. And what we should remember is y and f of x mean exactly the same thing. So all I would do is change y to be f of x. So this should say f of x equals 2x minus 4. And that's this one here. We'll scroll down to another random one. Let's try this one. It says, does the table below represent a linear or non-linear function? Well, remember, in order for it to be linear, my change in my x has to be consistent and addition, and my change in y has to be consistent and addition. So here I go up from 2 to 3, so that's adding 1, adding 1, adding 1. So far it could be linear. Then this one I'm adding 2, adding 2, adding 2. So again, both are consistent, both are addition, so therefore this is a linear function. Let's scroll to another random one. It says, which of the graphs represents the function? Well, it says negative x plus 2. So we know negative x means it's going to go down as we go from left to right. So it can be this one or this one, not this one or this one. So it's got to be one of these two. And it has a y-intercept at positive 2. So that means it's going to cross above the x-axis. Well, this one crosses below. This one crosses above, so it's got to be this one here. So you'll answer each of these questions. When you get to the end, you'll click Next. This will send you to your Before You Go. Fill out your Before You Go, and then submit your work on Google Classroom.